on the creature. Get it? Are you gonna wait like you're taking a shit in the caves? Of course you won't. Sit and think. So, damn, it's cold. Here, you bastard. Take that. Get him. Now you'll know what it's like in the comet latrines. You'll sit and think. So, gentlemen, a climate chamber is a good thing. It really cools the heads of haters. Welcome to the DP Labs channel. Let's get started. Today's video is about the HES heat pump factory. This is the third part. So what changes have taken place since the last video? Right now, we're already working on commissioning the conveyor and so on, trying to assemble heat pumps in semi-automatic mode. All right, here we go. So what changes have taken place since the last video? Right now, we're already working on commissioning the conveyor and so on. We're trying to assemble heat pumps in semi-automatic mode. Now I'll tell you and show you everything. Let's go to the first control panel, where we set up the automation on our conveyors. On the controllers for the operation of the automatic and semi-automatic refrigerant circuit filling system, and so on. What do we see here? All the terminal blocks on the controllers for operating the automatic and semi-automatic refrigerant circuit filling system, etc. What do we see here? All the terminal blocks, we marked and routed them right away. We use our own controllers and control system. We took a heat pump controller with specific firmware, attached 2 relay boards, and there will also be a control module and an RVM RVT type, something like an Irvin with electronic control. We will use them here for nitrogen purging, maintaining 200 millibars for soldering, as well as for charging, etc. There are a lot of ports here, so it will be easier to do this on our own controller. Here is what our RVM control board looks like. This is from an old type, like a heat pump controller, of which there are many. We ordered the rest, and here it is. It can control 1 RVM, 4 or 5 via wired connection. There is a 4 to 20 milliamp input and a separate pressure sensor as well as temperature sensors. There will be 16 of them installed here. They connect to the main controller, and from this controller, the data goes to our system running on Linux, where you can run all sorts of scripts, etc. We find this setup convenient to work with for what is our controller built on? Mainly, it utilizes an STM microcontroller for the DAC and for managing various additional functions. The main processor is an ESP32. We really enjoyed working with it, as it's very convenient and user-friendly. The controller itself features digital inputs, 4 to 20 milliampere current inputs, and 0 to 10 volt analog inputs. Then there's a PWM output, and there's also a dedicated output for heat meters that operates using PWM. Pulse signals. For heat meters, that's typically achieved with a Hall sensor, or for other types of devices as well, it can detect pulses. Basically, these relay boards here are equipped with solid-state relays for 3-way valve actuators and standard 10 amp relays. They're all connected through our interface box, which is capable of handling up to 4 such relays at the same time, and it also features a Modbus output for communication. Now we're going to connect everything. There are a lot of these panels, there's a lot of equipment, and on our own it's somehow, we'll see all of this in the system later. Now we're going to connect everything together. There are quite a lot of these panels and a significant amount of equipment as well. And in fact, it's actually somewhat more convenient to do it on our own. We're currently in the conveyor workshop. How will it work here in this particular area? Over there. Over there, they use a hoist to carefully place the compressor into a box where it will be securely housed. The shell, the benders, and all the tubes, they assemble everything right there with attention to detail. Then an automatic transport cart takes it to the soldering area. There's a robot over there, ready to assist. And we do all the soldering, as you saw in the previous video, using an inductor. Here's a 50 kilowatt inductor. Everything is soldered very precisely and accurately, ensuring quality. After the pump has been soldered, the automatic cart comes over here, and a person needs to So, gentlemen, now I will tell you about the filling ramp, which is located on the heat pump assembly conveyor. After the pump has been soldered, it comes up, the automatic cart comes over here, and a person will need to connect the hoses. Unfortunately, this is still done manually for now. Here, the lines for the refrigerant go to the warehouse with 3 different types of refrigerant, and then the nitrogen pressure testing line and the vacuuming line. The nitrogen pressure testing line and the vacuuming line. In our system, all of this will be scripted. The person only needs to connect the hoses, select the heat pump model, and the required amount of refrigerant will be automatically filled according to the scales. There are 2 such stations here. Everything is connected. All that's left is to set everything up and so on. Here on this ramp, let me add, if we set up an automatic Modbus output for refrigerant weighing, there will be a supply cylinder with refrigerant here, and the refrigerant itself will initially be supplied from the warehouse. Let's say 25 kilograms will be filled into this cylinder, and from there it will be used for refilling. Also, for safety reasons, even though refrigerants are not toxic, they can cause suffocation. We have gas pumps installed below. The refrigerant analyzers, which are important safety devices, are triggered by dry contacts at approximately 500 parts per million and also at 2000 parts per million. If either of these threshold levels is exceeded, an alarm will sound and the emergency ventilation system will be automatically activated to ensure safety. I think, of course, it's very unlikely that anyone would actually die from this situation, but just in case, safety always comes first. Besides, it's not particularly difficult or complicated to set up this system, since we manufacture heat pumps, which are energy-saving heating devices, and within our own factory, we are very attentive to energy conservation. For example, you see this 500-liter tank here. What is it for? When the inductor is operating, it is cooled by water. Water cooling is absolutely necessary. And through this buffer, the excess heat, depending on the season and so on, is either diverted to heating or for preheating the domestic hot water, but if there's nowhere else to divert it, then through a heat exchanger it goes into our fire pond. In other words, we never just dump water anywhere. We apply this approach to all our systems. So when the factory is running at full capacity, all the heat from the inductors, which generate quite a lot, will be used to heat the building. So gentlemen, we are now standing near So, gentlemen, we are now near the area for automatic soldering of the Freon circuits. How does this work? In that area, a person manually assembles the Freon circuit. He has pre-bent pipes, fittings, and instead of soldering, he puts on soldering rings and places the assembly onto this automatic cart using a hoist to position it. He moves the unit into position for soldering. The cart moves up here to this robotic arm, which has an inductor clamped in it, and according to the program, it solders all the connections. When soldering particularly sensitive elements like sight glasses and EEV TV, many people typically wrap them with rags. But we believe that's not a technological solution, so we made this device instead. We took it and cast it. It positions the housing for soldering. The cart moves to this robotic arm, which holds an inductor, and by the program it solders all connections. When soldering sensitive parts like sight glasses and EEV TV, many wrap them with rags, but we believe that's not a technological solution, so we made this device. We cast an aluminum fixture for the EEV. It goes here, closed with this clamp, and water is pumped through. The temperature inside during soldering stays below 55 degrees, which suits us. We made the sight glasses the same way. This one is for the EEV. There you go. So, we are now in the specific area where the main controller and other essential electrical components are installed into the refrigerant circuits. The automated cart system automatically brings everything here, and the workers then connect the pre-assembled and thoroughly tested controller to the temperature sensors and other important peripherals. In this particular case, as you can see, we were just carefully fine-tuning the refrigerant circuit for the heat pump of one of the adhesives. In this case, it is a 16 kilowatt rotary Mitsubishi inverter, which is equipped with our control system. Automatic soldering was used throughout the assembly process here. This particular heat pump features a heat exchanger specifically for providing domestic hot water. This is how the entire setup looks. Quite neat and tidy in my opinion. There is also an additional thermostatic expansion valve that is used for cooling the inverter. The inverter itself is located on the top here. We provide dedicated cooling for it. We cool the inverter with a carbon dioxide laser, which is a highly effective method. We believe this is better than installing fans, which tend to make noise and can break down over time. Here are some more heat pumps. These are start-stop models equipped with Copeland compressors. Everything is quite decent and works well. As you saw in the previous video, we cut the insulation with a carbon dioxide laser. It's very convenient. Everything comes out even, and there isn't much waste. Alright, let's move on to the next area. It's better if we go over there. So let's talk about the test chambers. Now we're in the area where the finished refrigerant circuits are tested. Here, workers connect the glycol circuit and the heat discharge circuit. Then the testing program is carried out accordingly. Also, for quick drying of the heat exchangers. Here there is a shallow vacuum line using a water ring pump to quickly extract working fluids. Up above you can see these pipes with valves. Flexible hoses will be connected here. Alright, maybe let's take a look in here now. So gentlemen, we are now standing near the climate chamber, which is used for testing air heat pumps, both air-to-air and air-to-water types. Previously, we demonstrated and tested water-to-water systems, but here, in this case, it's air-to-water. This is a sealed and insulated chamber. Here, air heat pumps will also be tested according to a specific program. They undergo a series of tests. We have 3 such chambers. Because the tests here are more prolonged, the chamber is well insulated. We use doors from the company Dobrograd. The prices seem reasonable. They specialize in refrigeration chambers. You could even put uncooperative people in here. We have 3 such chambers because the tests there are more prolonged, the chamber is insulated, and we use doors from the company Dobrograd. The prices seem reasonable, and since they specialize in refrigeration chambers, we like them. You could even put uncooperative people in here like give it to the boss. At plus 50 degrees in the chamber, and then minus 10 with 100% humidity. Also folks, I wanted to tell you about these markings on the floor. These are markers for the automatic transport platform to navigate. It uses them to determine where it needs to go and where it shouldn't. The positioning accuracy isn't down to the millimeter, which suits us just fine. We just stick them on the floor and it works fine. The positioning accuracy isn't to the millimeter. We built this crane beam. They wanted a lot of money for it, but we just took a hoist and welded these beams. We need this so we don't have to lift compressors by hand to assemble compressor blocks and move them onto the robotic cart. You can see it. That's the robotic cart. It's very convenient to use. As you saw in the previous videos, it needs to drive up to the soldering area and so on to perform its tasks. I bought a separate crane beam for it because buying a complete set was simply too expensive. We got a hoist up to 500 kilograms is more than enough, and it works just fine. It has a large area here where it can move around freely. We needed to lift compressors from the warehouse and other heavy components so people don't have to strain themselves, and to place them onto this automated moving thing, so it can transport items to the soldering area and so on. You can see that compressor units are assembled right here in these racks, and soldering is done in them as well, after which they are placed into the casing. Let's move on. Here is another soldering station and a charging ramp. We have 3 such stations. Let me remind you, once again, this is a Chinese 30 kilowatt inverter. It works quite well overall, although it does have its own flaws and limitations, but it's affordable and reliably gets the job done. It can easily solder copper up to 1 inch thick. The rings are put on and the soldering process happens almost immediately. So here we have the area for assembling the electrical components, performing soldering, and so on. Here we have the workspace. A wire cutting machine. It strips the wires, cuts them into pieces of the required length according to the program, and even crimps them. A wire cutting machine, it strips the wires, cuts them into pieces of the required length according to the program, and comes out already stripped. That's what it looks like. It's not expensive, works well, and there's a pneumatic ferrule crimper, so you don't have to squeeze by hand. It crimps for you, otherwise your hands would get tired. There's also ventilation for soldering, so everything is done properly. That's it. And this is the area that has been set up specifically for research and development, also known as R&D. It is equipped with 3-phase variacs, which are devices that allow you to simulate voltage drops, including drops in different phases and similar scenarios. This setup is intended for R&D purposes, providing a space for testing and evaluating everything thoroughly. There is also a dedicated test bench for controllers, and this bench is equipped with software that enables you to simulate a variety of conditions, making it possible to test everything in detail. We made this one ourselves. It shows the position of the electronic expansion valve's rotation. It needed to be tested somehow, so we set it up like this for demonstration. You can also simulate it just in case. That's how we check it, especially when the software changes significantly. This tool here is a wire stripper, which is used to protect the wires. Most people know what that is, but it's good to mention for clarity. Take a look. This is our inverter, one of our prototypes. It's constructed on a Mitsubishi IGBT module. About 1 kilowatt is capable of delivering up to 5 kilowatts electrically, up to 7. It's fully functional. We're making some minor updates to the current version. This is for frequency-controlled heat pumps. Let's move on. So, gentlemen, this is the NeoCard chamber. We can, as you can see here, there is also a source and condensation, like a source of low potential heat, and we can condense it into some kind of heating system. We can run heat pumps here. There's also a powerful fan coil installed, so we can run air units as well. And we also supply steam from an ultrasonic steam generator here, so we can adjust the humidity. So right now, our new inverter is being tested here. Here it is running. Everything here looks a bit thrown together, but that's perfectly fine for our testing purposes. Let me show you the new models that have just arrived. These are the latest versions, and you can see them right here. Over in this area, gentlemen, are the test chambers. These are the spaces where we conduct our experiments. Here they are, right in this section. In these chambers, you have the ability to test at different temperatures, and you can also supply a variety of different refrigerants to see how the systems perform. In this part of the facility, we will be testing the air units, carefully observing how they operate under various conditions. There are 3 of them in total. You'll be able to drive in and out automatically without any manual effort and get tested. By the way, we really like these doors from the company Promkul. They make them quite well. And here is the testing area for water-to-water systems, or for systems that include a geothermal circuit. That's how it is. And here, this part is specifically designed so that the vacuum line connects in such a way that when you disconnect it, the liquid doesn't spill out, but instead gets safely and efficiently sucked in. That's it. Here, hoses will hang down and heat pumps will drive up here for testing. Again, just to clarify, the crosswise one is actually being torn apart. So, gentlemen, as you can see, almost everything is finished here as well. There will be many valves. We'll use our control system. We're starting and everything will be automated. And now, Masha, let's take a look right over there at the ventilation system. Yes, take a look. Here we've installed our own system. We have automated valves and pipes, all pressure tested. Our custom aluminum ventilation system will be tested now. The stabilizer is malfunctioning again, which is frustrating. Maria, can you help? Let's check the cafe boiler room and turn it off. So, gentlemen, by the way, I would like to mention that our factory is now heated by a heat pump system. Previously, we used electric boilers for heating. Let me show you. It's enough for our needs. Right now, it's minus 18 or even minus 20 degrees outside, and it's still sufficient. Here we have a cascade system with 2 compressors, each rated at 16 kilowatts. That's it. It's more than enough. You only need to set a small supply here. Yes, so, well, if you take a look now, you can clearly see how effective it is. A supply temperature of 32 degrees Celsius is more than enough. This is our interface, our own dedicated controller. Look here, it's boiling at minus 7 degrees. That's how it works. And if you look at the source, here the source is 1.5 cubic meters. It takes in 2.4 and 1.6 goes out. Everything is fine. The source here is 1.5 cubic meters. We'll install another heat pump like this one for ventilation. For the floor, so 30 kilowatts of heat is enough for 1,500 square meters. And right now outside, let me check, there's no outdoor sensor installed. It's about minus 20 right now. It's a bit soundproof there. This was a test model, but well, it works. The entire boiler room is finished. Just some minor things left. There are a bunch of different recuperators and so on here. Well, it's all quite interesting. You can't notice everything at once. This is how everything works, and it's enough. It's very warm, about plus 23 degrees right now. Somewhere around here, a check valve is making a crunching noise, but it's nothing serious. By the way, here is the humidifier we made, the one they look at in the Neo core. It's just an ultrasonic assembly. Water comes in from the osmosis system, and then a fan blows the moisture in there. And what is osmosis? No, reverse osmosis is a thing that removes salts from water. It takes out the salt and hardness. Can you use it to desalinate water? Yes, that's right. All right, moving on. A bit of science pop. Yeah, a bit of science pop. Here we have a little office. Here's our CEO, Alexei, sitting here. Humble. Reverse osmosis can't desalinate much. It clogs fast unless you use special high-pressure systems. In our office, CEO Alexei, humble and smart, works with us. We have samples and components making progress. Bit by bit. Now, there are already a lot of orders. We have to somehow get it all done. Everyone's doing their best, and no one's really sleeping at night, fighting, so to speak, with the market. There are many orders, so we must finish everything. Everyone's working hard, staying up late and competing in the market. I believe things will turn out well, maybe even great. Let's see the laser. This is the bending machine. We'll add more about it later, including from here. Okay, we went the wrong way just now. Let's go this way. Yum, 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 yum. Gentlemen, I also wanted to show you a cool Uber device we made, since we have to flare a lot of pipes and you'd go crazy doing it by hand. We took these ends from a pipe flaring tool. They're interchangeable, these expanders, and a hydropneumatic cylinder from a KAMAZ clutch. Right now, the pneumatics aren't connected, but if someone turned the valve. So you press, and with this, with pneumatic amplification, you insert the tube and release it. Very convenient. If it breaks, it's sold everywhere. This is the kind of device that turned out. Very convenient. Here. And it absolutely wouldn't have been possible without our own crucial emergency bending machine. Close press and insert the tube with pneumatic help. Very convenient. Replacements are easy to find. The chip bending machine is assembled by us. It's a mandrel-less bender. We bend pipes with it. Very convenient. The repeatability is pretty good because fewer fittings are used. Less soldering. It's not that expensive either. You just can't cut things out this well by hand. Insulation for heat exchangers and so on. It cuts quickly. I made a cover for it because of the smell. The machine cuts insulation sheets much more precisely and quickly than by hand, reducing waste. All right, let's go. We've been waiting for this moment, preparing ourselves and making sure that everything is ready. The anticipation has been building, and now the time has finally come for us to move forward. As we take this next step, let's remember all the effort and dedication that brought us here. With excitement and determination, we set out together, ready to face whatever comes our way. Let's take a deep breath, gather our courage, and begin this journey with confidence, knowing that we are prepared for whatever lies ahead. All right, let's go. Stay tuned for more.
Make a big course there. Now let's go ahead and do the general tense together. For example, let's move on to the next step. Well, gentlemen,
We are slowly and steadily getting closer, roughly speaking, to the full launch of the factory. For now, we're still making test batches of something, fine-tuning things, so subscribe to the channel.